Well, my friends, we have made it to Friday afternoon, and I'm very excited about that. But I'm more excited to be here on the Siemens booth for part 2 of what we're going to talk about here today. John, quick introduction before we get into all this really cool technology here and what we consider the additive section, but we're talking more than additive today, aren't we?
Well, absolutely, Tony. It's, as you know, it's the second to last day of IMTS. It's been a really exciting week. Yesterday we talked about the production of this innovative part. We went from the blueprint to the finished piece. Today we want to talk a little bit more about our digitalization solutions. We want to talk about our additive manufacturing offering. And most importantly, we really want to talk about our new CNC controller, Sinumerik One.
I love how you ended that because I believe that's the first thing we're talking about with Rowan is that new technology. So with that being said, let's get it over to Rowan and start this party.
Absolutely. Thank you very much, Tony. So we're going to be talking about Thank you very much, Tony. We're going to talk about the Sinumerik One control. This is brand new. Come on, Jiangsu. Come and show me the brand new Sinumerik control. Get in there, cameraman.
Yeah. So Sinumerik One is Siemens' latest flagship CNC system. So it is the first digital native system, and that means when we start defining and designing this control, we considered all the challenges our customers may meet during their digitalization transformation.
Absolutely, and we've learned a lot in the past 15, 20 years, I guess. Maybe even the past 2 years, we've had to adapt the way we do business. It's not the same way as the old Sinumerik 828, which are known and loved across the world. But we've got to keep updating, haven't we? And can we move on to just talk, before we continue about the operator experience with the standard Sinumerik One control, can we just talk about what's happening here, please?
Yeah, so this is the biggest innovation together with Sinumerik One. So that is the digital twin software developed together with the...
So what we're looking at here is a full control simulated. So you said it's the exact same kernel.
Yes, so you have the same NC kernel, same PLC running in the software as those running in the real controller.
I don't know if I'm allowed to say this, but it's almost like a vericot or a verification software that is doing exactly what the control on the machine in the real world will be doing, but you can sit there and relax because it's not happening, it's not going to damage anything.
Right. That is the important part, that you only damage the software. And
well, you don't even damage it, so you can reset. Yeah, exactly.
Yes,
you can hit reset,
that.
Clear everything out.
Yeah.
Oh no, we had a little smash, but it's okay. It's only pixels.
Yes.
Okay. And what we're looking on the left here, what is happening here?
So here
on the right.
On the right side, yes. So here is the additional part that not only simulating the control, but also simulating the whole cutting process, which is also important for the end customer, that you can see if the cutting is correct, you can see the material removed, and also some of the time there may be collision, and you can see if there's a potential collision there, and then, as you mentioned, you do not need to worry about that collision will damage any mechanic. It's just damage whatever is seen here and reset everything.
And what we're looking at here is quite a complex, it's a robot on a sliding rail with a 5-axis bed. There's a lot of complexity here, and there's a lot of times when, with this kind of complex system, you want to be sure that what you're programming and what you expect to happen is actually what's going to happen.
Yes, the more complex the machine is, the more value you can get it from here. And one thing I want to mention is, even you see this very complex, it will be very easy to build them with the software.
Absolutely. But complexity is not just in, there's not many companies who are using machinery like this, but you still get complexity. If you get a standard budget vertical machining center, you plonk a rotary table on it, suddenly you've got interaction between relays, M codes, there's so much going on. That is actually a lot of complexity, and that is probably in machine shops all around the country and even around worldwide.
Yes, and also the more benefit they can get is they can have the machine running while they can do, even for those standard simple machine, they can do all the tests of their different parts, different tools here in the virtual environment. And once they test everything, they find that there's no collision, the part program is correct, the feed rate is correct, then they move to the real machine. They do not need to slowly test. Everything is full power.
You can fully trust it, and this is a very cheap way of testing all of your products before you have to buy, machine, make fixturing, off-the-shelf products.
Electric.
Exactly. You're using a little bit of electricity, which we all know cost is going up a little bit, but that's a hell of a lot cheaper than buying fixturing and tooling. Let's move on to the control itself now. And rather than, we're going to talk about the operator experience. Now, how much has changed? Can operators who are used to an 840, can they jump straight on this control?
Anyone who used 840 solution line before, they have no difficulty in moving to Sinumerik One. So all the programming, operating, they keep the same. The only difference is Sinumerik One not only offering the digital twin option, but also the more powerful power calculation power, so which makes it possible to get more add-on apps, features, and also together, like 840D solution line, we are offering all the features not only for the traditional milling, turning, grinding machines, and also those new technologies like the additive we are talking about, and more and more people talking about the robotic as shown in this digital twin. So all the technologies can be supported together by the Sinumerik One, and together with Sinumerik One, we developed other software apps to help the customer to not only having those new technology, but also helping them to easily connect the machines with the internet and to get the data out and to analyze those data to optimize the process, the process according to that data. So we have the whole portfolio to help different kind of the customers, those big customers who has huge facility, or those small customers who just want to simply understand what the machine is doing and having out-of-box apps. So you can.
Thank you very much, Shanti. That's fantastic. So a control for everybody, whether you're in a small machine shop or a big machine shop. If you've got any questions, if you love the Sinumerik control, just let us know. Even if you're running one of these Sinumerik ones, let us know. We'd love to find out in the comments. With this, we are streaming live. Now over to Tony. We're at IMTS 2022.
Now we get to talk about one of my favorite topics, which is additive manufacturing. I got Rich standing with me here, and we're going to talk about CATCH. He's going to tell you what that acronym is, but to get started, I just have to tell you, reimagine your products, reinvent your manufacturing, rethink your business. Rich, let's talk about what CATCH actually is.
Yeah, so we're excited here this week to talk about CATCH, and it's a facility that we have in North Carolina, Charlotte, North Carolina, and CATCH stands for the Charlotte Advanced Technology Collaboration Hub. Collaboration being the key. So what our focus is to help industrialize additive. And we're going to do that by not only are we sellers to the additive market with our hardware and software, but we're also big users of additive equipment. So we have 300 machines worldwide using different modalities like powder bed fusion, material jetting, binder jetting, and I'm missing one in there. But
that's all right. When it comes up, which is when we're talking about another subject, you're welcome to say it. Don't worry about that for now. I also want to talk about, when we're talking about CATCH, and we always want to push for questions, and I know you're going to have some for Rich, because Rich, this facility, correct me if I'm wrong, you invite people to come in and learn about how additive manufacturing happens. You educate them because you are a leader in that, and let them go out into the world and do it on their own. Is that kind of how this all works?
Absolutely. So for those people that are struggling with, or those companies that are struggling with designing for additive, trying to find out what modality works best for them, material development, validating the process, we've been through all that here at Siemens. So we'd like to share that information with them, teach them how to do that, and release them out to do it on their own.
And now that they're out there doing it on their own, they're just running wild, doing a bunch of additive manufacturing, getting creative, right? There's a whole lot of, I think we can do this, I know we can do this. Additive manufacturing has been utilized in so many different areas of our industry. Where do you think additive manufacturing is currently and will grow into, instead of just maybe parts being printed to do soft jaws, which is an important thing, don't get me wrong, but there's so much more to it, isn't there?
Right, absolutely. So it's still the wild, wild west out there. And in the past, people think of additive as creating these sexy parts. These sexy parts are what need to be with additive. And really that's not the case. So we need function. We're starting to see that with not so much sexy parts, but the simple things. The simple things where it be different material or a little faster printing, with combining parts together, or different brackets you can use. The different, some things that you don't always think about, that maybe not as sexy, are more applicable to using the additive equipment.
I mean, I don't know about you, but I'm sexy and I know it. So with that being said, let's look at some of these parts and showcase what's going on here. We have all the different materials, cool designs. Some of these parts are sexy, some a little less, some are more practical, but just kind of go over what these are that the audience is looking at right now.
Sure. So we have like our DED applications using the Meltio system. So this is a traditional part that was machined out of a block of Inconel. And if you guys know what Inconel is like to machine, it's very difficult. So in this process, not sexy, but it's very applicable to be able to print quickly and machine only the parts necessary. We've got some Ultim material here. This part right here is a blocker that was normally made out of crushed glass. 5 different other parts went onto this. So we're able to print this in Ultim and just machine the holes that are necessary. We've got
Let's talk about this fancy looking one right here. It looks like an underground universe of some sort, right? But this is actually a really quite a heavy and durable material. Looks like a nickel alloy, and I don't know about you, but when I machine nickel, man, it's not my happiest of days, you know what I mean? So let's talk about some of this harder materials also.
So yeah, so this is a heat exchanger used for the for DoD, and we used our Siemens Star CCM for this, as well as the Siemens NX hardware or software for designing the part.
Before we send this over to Rowan, would you like to elaborate any more on the Charlotte Advanced Technology Collaboration Hub, or even just throw out a website or something where they can find you? If anything that you'd like to say about what we're calling the acronym CATCH. Catch Me If You Can, Catch 22, whatever you want to call it. There's lots of them out there. Would you like to describe to the audience anything more?
So what we'd like you to remember is the collaboration is the key. It helps move the technology. So we have this saying that if you want to go fast, you go alone. But if you want to go far, you go together. And that's the collaboration that we're trying to do.
Well, with that being said, let's send this over to Rowan and go together over here.
Okay, thank you very much, Tony. And I'm here with Steve. We're talking about something I might find a little bit of a struggle to get my head around, but it's digital engineering services to make digital twins. Now, give us a little high-level view. Who's going to be using this kind of service, please, Steve?
I mean, I could see anyone using the service. Honestly, it's going to help you design the entire process from A to B, multiple different scenarios, if-then use cases. Essentially, if your shop ever experiences a bottleneck or any type of irregularities, you need to be prepared for that. You can't really just go out and make a decision without knowing exactly how it's going to perform before it actually happens. And that's what we're really showcasing here is this digital enterprise, this digital thread that allows you to plan that entire process from beginning to end, making sure that when you make decisions, you're going to make the right decisions towards the future.
And we're talking big projects here. This is like factories that haven't been built yet. You're going to be laying the groundwork in maybe a couple of years. And you want to really dig into how many parts you can make once that factory is built, once you've got all the machines in. And it's a long process. If you're going to do that physically, it will take a long time, a lot of cost investment. What are the benefits of doing it all digitally?
Yeah, I mean, for one aspect, it is a large-scale project, right? You can definitely make an entire facility, but you can also make it down to the individual line. So if you're evaluating just one machine, a line of machines, like developing a bottleneck in between the two, or the entire factory, really this application kind of fits in each one of these use cases. And here at Siemens, with our consulting service, we're allowing you to utilize our knowledge, our expertise, and kind of guide you along that entire journey. So we're able to support, consult, implement, and really develop the entire scope of that process. So you really don't have to. You don't need to worry about the concerns or am I making the right decision. We develop this all in a virtual environment to ensure you have multiple use cases, A, B, and C, evaluate which one best fits your needs, and then from there you can train your operators as to this horrible instance happens and how are you going to react to that.
And there's a lot of cases where you've got to come up with what-if scenarios, right? And there's protocols for if a machine goes down, do you put the whole assembly line down, or do you try and replace it? Do you try and just skip that process in some way? And there's a lot of complexities that you just don't get with a back of your notepad little sketch, a time study, even a myriad of spreadsheets trying to get the time studies right and everything. There's all these little complexities that you would never would have thought about until you start digging in and diving into the real complexity of implementing a factory or a production line.
Correct. And that's really why Siemens is here and happy to help, because you really can't accommodate any type of use case and you really can't be prepared for, anything that's going to happen to you without that digital environment. So in this scenario, we can throw in these if-then statements. We can throw in a machine downtime, and how's that going to affect your production line? How's that going to affect your output of products? How's that going to affect your engineers on the shop floor? Are they prepared to encounter these type of bottlenecks or problems that might happen?
Absolutely, and once you have an action plan in place, even before you've dug that first piece of foundation, you can be really sure that that huge investment you're making into a factory, which could be run into, I don't know, the hundreds of millions or the billions of dollars or pounds, wherever you are in the world, that you can be rested, you can probably sleep at night if you're the one heading up that project and making sure that it's absolutely right, as long as you've done that diligency. And can we just talk a little bit about now? This software is available on the market, companies can buy it and use it. Why should they go for an enterprise service from you to help them build these systems? Why can't they just do it themselves?
Oh, I can't imagine the amount of work it would take for someone to just build this themselves. Because from one aspect, sure, we have the entire enterprise suite. We also have the consulting services and the knowledge and the expertise in-house. And that's really what we're offering today is this entire digital enterprise service that allows the consulting of Siemens experts to come in, assist you with the entire scope, and really build out your vision of what the factory should be.
And these are experts that have had years in the field actually implementing the real systems, not just the software systems as well?
Absolutely. We have both experts just from the machine side as well as the virtual side. And really the huge advantage of our digital twin, for example, is that one-to-one ratio of having a virtual numerical controller in a virtual environment that's a one-to-one ratio of your actual machines on the shop floor.
Right, okay, so this is exactly simulating, almost like we saw on the Sinumerik One earlier, it's exactly simulating what each control on the machine is doing, what all the robot arms are doing, what about all the passing from process to process. It's a fully comprehensive solution that you probably couldn't get many other places. What makes you think Siemens is well suited to provide that service? I mean, what if people are integrating different machine tools from other providers?
Well, we've been doing it for years. So I have the full confidence in our team and our service team to go into any field on the shop floor and implement the best possible solution we can.
Okay, best possible solution from Siemens. I'm going to hand you over to Tony, man. I think he's walking in from the left here. We're going this way, Steve. Let's go.
Yes, we are, and I got my buddy Gus with me. We're just sliding to the left, aren't we, Gus? How we doing, buddy?
I'm doing great this afternoon. How are you?
I'm living a dream. So what are we talking about? We like to dive in right away. The audience loves technology. They love Siemens as well, and we're going to learn a bit more about what we're doing here, right?
Absolutely. So what I wanted to showcase here is Siemens Adaptive Control Solution. We call it Optimized Machining Adaptive Control. This is a piece of software that's going to essentially monitor the load on your spindle in real time and use that spindle load in order to dynamically adjust the feed override at the machine. It's going to bring two benefits to your shop floor. One, it's going to reduce cycle times by increasing that feed override when you're air cutting or you're underloading the tool. And then when you're overloading the tool, it's going to dial back that feed override, which is going to increase your tool life. In the case of our Sinumerik controls, it's a software-only based solution. So we come in, we install some files directly on the CNC, and we get a new soft key that just shows up on the HMI, and then you can bring up this screen that we're seeing right behind us and start making use of the software from the get-go that day.
Well, I'm going to step over with you so my camera guys can slide in as well and we can talk a bit more. But when you're talking about adaptive controlling, are we quite literally saying that I've programmed a machine, I've programmed it poorly, it needs to have better feed rates than I've programmed it for longer tool life, better finishes, better machine, like everything included is because I'm a bad programmer?
No, it's really designed to act as a complement to your programmers or your CAD/CAM system. So it's going to account for things like differences in the hardness of your material or differences in dimensional tolerances. And because of the fact that it's doing this in real time on the real part, it can account for those variations that you can't get in your CAD/CAM system. So it's really just designed to benefit the operator or benefit your CAM programmers.
Yeah, that makes much more sense than what I just said, and I agree with you. I just wanted you to convey that message. Now, correct me if I'm wrong, would this be really good in something like a forged material, where sometimes there's gaps in how there's bubbles and how it's being forged together, and sometimes it's just there's imperfections in that in there?
Absolutely. Talking about imperfections or castings where you're really going to have that change in hardness as you move deeper into the material. That's really where adaptive control really shines, especially in those roughing operations where you want to try and speed up your feed override. You're not so worried about breaking a tool. That's where we can really shine.
And this comes with the Siemens as a whole, right? A lot of times there's outside companies that come in and support this type of operation, but this is Siemens, we can do a lot of different things and we're here to help you kind of a thing, right?
Absolutely. So it's a package that we can install directly on our Sinumerik control, as I said, with no hardware. We also do offer the ability to connect to other CNCs from other manufacturers. In that case, we just have an IPC we install in the cabinet that's going to interface with the CNC and your spindle to get all the data we need so that we can foster this adaptive control.
From my perspective, Gus, when I'm looking at something like this, just knowing that I have a commodity item like end mills and how quickly I can go through them, I would think this pays for itself in a matter of a day or two, depending on how hard the material is. Obviously a little bit longer than that, but when I'm talking about being able to automatically adapt to these difficult materials and how much tool life I'm going to save, and maybe even scrap part or second, third operations trying to get those finishes, this really does increase productivity, doesn't it?
Absolutely. So, you're going to see that increase in productivity either by reducing cycle time or extending tool life. And one of the benefits I would say with our solution is the fact of how easy it is to use. You essentially run a part once at 100% feed override. It learns your load profile. And once you've done that, you can put it into adaptive mode and start having your dynamic control from that point forward.
Well, I love this topic, and I love what it does for everyone, but I know you have something else you'd like to discuss as well. Otherwise, we're going to be here for the next 20 minutes discussing how we can create the productivity through that platform. It's just really cool, but I know you want to actually go into, it's not technically machine monitoring, but I guess it kind of is as well, right? How would you describe it?
Right. It's supposed to help someone who's really starting their digital transformation on the shop floor. It's supposed to offer easy connectivity from your machines to the cloud, whether that be from our Sinumerik controls or if you have machines that are running MT Connect, OPC UA, Focus 2. It's supposed to be an easy connectivity solution to start getting data into the cloud. So we're talking about information like stack light data. If you're running in operations, are you in jog or auto mode? What are your overrides looking like? What alarms are present on the control? It's really supposed to just start giving you a dashboard and giving you an overview of what's going on your shop floor. And in the case of our Sinumerik controls, we also have the added benefit of being able to remotely access the machine HMI to provide service personnel the ability to remote in, see what's going on directly on the shop floor, and provide help to their operators. So here we can see essentially the HMI of a machine that we have at our facility that I'm able to remotely access securely, remotely, whenever I want to see what's going on at the machine. Let's make adjustments to the part program. Let's see what alarms are present, and let's get this machine back in production.
Wow, talk about a massive stress reliever if I'm the guy on the machine asking for that help. Gus, if I don't end this conversation, you're going to take my job. You are way too good at this. For everyone who's watching, you guys know Siemens, but if I'm going to give them a website or something to look up just to find you guys out there, do you know that website?
Yeah, if you go to just siemens.com/machine-tool-digitalization, you'll find us.
Or Google, or pretty much anywhere. It's Siemens, guys, right? With that being said, Gus, very well done. I hope you've all learned as much as I have today, and we'll see you again soon. Thank you all for watching.